Okay, Sai, so let us start your full mock for ISRO.
Yes,
Please
sir.
introduce yourself first.
Yes, sir. Good afternoon, sir. I am Sai Rana from Odisha. I have done my B.Tech in Mechanical Engineering from Vir Surendra Sai University of Technology. It's
Can you
also
please talk a
so.
bit louder?
Okay, sir. Sorry, sir. I have completed my graduation from Vir Surendra Sai University of Technology, Bulla, which is also situated in Odisha, in the year of 2023. Uh, After that, uh, after my graduation, I joined Adani Power Limited, a power sector company, so campus placement, where I worked for almost 1 year. Uh, I subsequently resigned the company to focus my entire study towards ISRO and GATE examination. And in this year, I have secured a All India rank 233 in GATE Mechanical Engineering with a score of 730. And uh, talking about my hobbies and interest, I like to
Right
play in
now,
the
what are
free
you
time. I
doing?
like to currently I am studying from for exams like ISRO and GATE. And
Okay, okay. So
talking about my
what was the work in Adani Powers?
Uh, in Adani Power, actually, I was in training. My time was, we were trained for whole power sector control. I was not assigned till my resignation. I was not assigned at any specific sector.
Okay, okay, okay.
And
Okay, so, okay, okay, Sai, good. So, can you tell me some ways to generate powers?
okay, sir.
The basic
So,
ways yeah.
okay, the basic ways are generally involved like we use thermal energy, first of all, thermal power plant, which is also called. The thermal energy can be generated, derived from either coal or nuclear power, and uh, and geothermal energy also. Heat from the internal energy of Earth that also can be used to generate power. Other than that, wind power, windmill, and hydroelectric power. What we use the potential energy of water to generate power.
In airplane,
These are the
I mean,
ways.
how do we produce power? In airplane, how
Oh,
do we
so
produce power?
in in aeroplane also it's called gas generator. With the help of the kinetic energy of air, we generate power, sir.
How do we generate power with the help of kinetic energy of air?
In gas, in rocket, which is also called jet engine. Here we compress the incoming air
What
by
is the name
series
of
of
the device? What is the name of the
device.
device that is used to generate power in airplanes?
Gas generator, open cycle gas
Gas,
generator.
gas generator,
Yes, jet
gas
engine.
generator.
Yeah,
See, gas generator. This means that it will generate gas.
uh, I mean that means using gas we are generating power.
Acha, acha, okay, okay. Acha, which cycle do you use here? Which ideal cycle?
Uh,
Thermal power cycle.
Here we use Batten cycles.
Brayton cycle.
Yes,
Okay. So, uh, see, there are two kinds of Brayton cycle, closed and open.
yes, sir.
So, which
Yes, sir.
one will you use here? Open or
Uh,
closed?
in in rocket engine we use. In jet engine we use open cycle gas, open
In a
cycle
commercial
Batten cycle.
plane, let us say
Uh,
that you are flying from Kolkata to Delhi or from Mumbai to Pune, So
Yes, sir.
you are flying on a plane, right?
Yes, sir.
So that plane is using which cycle, closed or open
Open
loop?
cycle.
Why?
Open cycle. Why?
Why?
Because the incoming gas and the outgoing gas are, I mean, incoming gas is taken from the atmosphere. Also, the outgoing gas also given out to the atmosphere. There is no, I mean, the working fluid air is not circulating. That's why it's an open cycle.
Acha, if we circulate the air, then
Yes,
what
sir.
can be a, I mean, what can be a potential problem I mean, compared to a open cycle if we circulate the air?
Okay. In open cycle, the exiting air has very high pressure and very high temperature. So if we reuse the air, the exhaust air, then the entire system temperature will keep increasing. Also, also the exit air will have a higher specific volume. So to the compress again the higher specific volume, we need very
Acha,
much
acha,
larger.
if you have a closed bowl, okay,
Yes,
in that bowl you have water at room temperature and at atmospheric pressure. You have a closed bowl. So how can you make
closed
the
bowl.
water boil without changing the temperature?
You have a closed bowl, room
Closed bowl,
temperature, room pressure.
yeah, closed circular bowl like this, and you have water in this. Okay. So how can you boil this water without changing temperature?
Okay. We are not changing the temperature.
No, we are not
In that
changing the
case,
temperature.
I mean, we can decrease its pressure by changing its elevation. By that also we can,
So you are
I
saying
mean,
that uh, by decreasing the pressure,
pressure.
we can boil it, right?
Yes,
Okay, 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 good. Okay. So now you tell me that in fluid mechanics there are so many equations, right? Navier-Stokes equation,
yes, sir.
Euler equation, right? So in comparison to an aerofoil, you know an aerofoil,
Aero-
you know that?
Yes, sir. Yes, sir.
What is an
Uh,
aerofoil?
Aerofoil is a aerodynamic device used in any flying object like aeroplane or helicopter, which used to generate lift.
Generate lift. Okay.
Yes,
So if you consider an aerofoil, so
yes,
can you tell me that in which section I will use which equation? So for example, if I just draw it, so maybe
yes, sir.
this is my aerofoil, okay,
Yes, sir.
and the air is flowing over it, okay,
Yes,
air is flowing over it.
yes,
So
sir.
can you tell me that in this situation, in this situation, where I will apply which equation? I have so many equations. So, okay, I am also telling you, out of the Navier-Stokes equation, the boundary layer equation, and the potential flow equation. You take these three equations and you have to tell me that where I will apply which equation.
Tensile flow equation is used for irrotational. So, so it will be at a very higher level to aerofoil. We should use potential equation. And boundary layer equation, um, near the surface, we can
Hmm.
use the Navier-Stokes equation because of the viscous effect
Near the surface, we will
should be
use the
there.
Navier-Stokes equation.
Yes, sir.
Okay, and
And
the boundary layer equation.
and will
Achha,
do.
the boundary layer equation, is it, I mean, totally different from the Navier-Stokes equation?
No, sir, I don't know, sir.
Okay, okay, no issues, no issues. Acha, you tell me that uh, you know that what is the difference between steel and cast iron?
Yes, sir.
What is the difference?
The basic difference is the carbon composition. In the steel, the carbon composition is up to 2.1%, and in cast iron, the percentage is generally 2.1 to 4.3%. We can also take it up to 6.61%.
Okay. And what are the phases in the cast
Uh,
iron in the cast iron? I mean, so let us say that we have 0.9%, 0.9% carbon, and
okay,
also we have, let us say, 3.4% carbon, right?
okay.
0.9% and 3.4% carbon. You have to explain
Okay.
the microstructure there. What will be the
Okay.
microstructure?
Uh, the 0.9% carbon is
And the
at
temperature is below the
yes,
yes, and the temperature
the
is
temperature
below
is
the
also needed.
lower critical temperature.
Okay,
Temperature is below the lower critical temperature for both.
okay. The lower critical temperature is near about to 725 degrees centigrade, and 0.9% carbon is at hyper hypereutectoid steel region. So it would be perlite plus cementite, the 0.9% carbon. And the 3.4% carbon is at hypoeutectic cast iron region. So here the composition should be uh, the composition should be perlite and pro-eutectoid
Acha,
cementite,
which
I
one
guess.
is more ductile and which one is more brittle?
Okay, the 0.9% carbon would be more ductile and 3.4% carbon would
Why?
be more brittle. because
Why
uh,
it is so?
because when carbon composition increases, it's occupy higher amount of interstitial site. So it
So,
makes a intermetallic for the cementite, which makes I mean uh, carbon iron alloy more brittle.
okay, 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 okay. Can you draw the graphs for mild steel and cast iron? The stress strain graphs.
Station.
Yeah.
So,
Which one is have higher toughness?
the toughness of mild steel is greater because it
What
has
is toughness?
toughness is a material, the ability of a material to absorb strain energy up to its ultimate failure.
And which one is having more resilience?
The resilience is related to the strain energy absorption up to its yielding.
So which one is having more
So,
resilience?
so the resilience of cast iron is higher.
Okay, okay, fine, fine, fine. Good. Okay. So now can you draw the graph for rubber?
Yes. I guess, sir, I'm not sure. Rubber is something like this.
No, you have to draw in the same graph.
Okay. Rubber should be something like this, the lower one. The lower one.
Okay. So, do you know about phase change materials?
Yes, sir.
So, what are those? I mean, what is
H
a phase change material? PCM.
H change?
Phase change material, PCM.
Sir, actually, I don't.
Okay, okay, okay. No issues, no issues, no issues. Acha, you tell me, last question for you. You tell me that uh, if I have a if I have a pressure cooker, right?
Yes,
If I have a pressure cooker, in that water is there at atmospheric temperature
yes, sir.
and pressure,
Okay,
and the specific volume of water is less than the critical volume.
okay. The critical volume.
Yeah, specific volume of water is less than the critical volume, and it is a two-phase mixture. It is a
Okay,
two-phase mixture of
okay,
water and steam.
okay.
So if I now heat it,
Yes,
okay, heat it for sufficiently long enough time, then what will be the final state? Will it be a two-phase mixture? Will it be a superheated vapor, or will it be something else?
okay. And so if we heat it for a longer time, and I am assuming it's a constant volume pressure cooker, then in that case, it will, after a sufficient time, it will convert to saturated liquid.
Saturated liquid.
Yes.
Okay, and if I heat it more,
It will become subcooled liquid then. In that way.
okay. So can you draw the graph and show me?
I've drawn it already like this.
Okay, okay. Sai, your interview is over. Let me know the feedback. Let me tell you the feedback. Okay.
Yes, sir.
So your performance was pretty satisfactory, pretty much satisfactory.
Mm.
That was good. Now, in the introduction, make it a bit short, and also whatever you have told, that was perfectly fine. Try to tell the timeline, sir. Between this to this, I have done this. Between this to this, I have done this. Currently, I am doing
Okay,
this. Okay,
okay.
and
I
my
have to make
hobbies
it
include
or
this,
more
this,
shorter.
this. Short. I mean, see, the material that you have included, that was very good for the
Mm.
introduction, but make it a
Yes,
bit
sir.
crisp, and also you can
Point to
include your
point.
hobbies. That is okay. Okay, but don't think much, but just say as the last line that my hobbies include this. That's enough,
Okay, okay, okay,
right? Okay. So, and okay, and now talking about your technical part,
okay,
uh,
sure.
almost all the things were good. Okay, but this thing, that which equation should be used for this aerofoil
Yeah,
thing?
I was confused.
Yeah. So I think you need to revise these equations, the basics of this equation. See,
Okay,
boundary layer equation is a simplification of Navier-Stokes equation.
I I was unsure about that. That's why
Okay.
I didn't
So
tell that.
near the surface, see, ideally everywhere you should use the full Navier-Stokes equation, ideally. But
Yes, sir.
but near the surface you have the viscous effect dominating. So if the flow
Yes,
is laminar throughout the surface, and I mean, doesn't matter if the flow is laminar or not laminar. If the flow is not separating from the surface, you know boundary layer separation.
yes, sir.
So if the flow is not separating, you can use the boundary layer equations inside the boundary layer. Outside the boundary layer, you can use the potential flow. You can use the potential flow equation outside the boundary layer if
In
there
the
are
set
no
flow
shock
also.
waves. If there are no shock
Ah,
waves.
yes, sir.
If there are shock waves, then there will be irreversibility and there will be rotation, right?
Okay.
So there you cannot use the potential flow equation, okay, if there are strong shock waves. So potential flow equations are only valid for maybe a bit up to supersonic flow, not exactly supersonic flow because there also shock exists. Okay, so
Transonic almost.
yeah, transonic. Transonic is the range. So maybe sonic and transonic. Okay, I mean
Okay.
not sonic, subsonic and transonic. These are the ranges where you can apply the potential flow.
Uh,
Okay,
Potential.
and actually these are the simplification of the full Navier-Stokes equation. That's all. So everywhere you can apply the Navier-Stokes equation. See, I mean again, so for the material science also, I think your answers were good. Just for the rubber, it will be you have
Uh,
drawn it like this. So
Upward.
that is
It was
wrong.
upward.
Yes, yes, it will be upward.
I
Otherwise, it was right. I
mean,
mean,
I
it
was
will be
not
below
remembering
the mild
correctly.
steel and cast iron graph. That is perfectly right. Okay, and your material science knowledge was also good. And your at first I asked you that what is the device that is generating power in airplane? That is gas turbine, not gas generator.
Okay, okay, sorry. Yes, sir.
Right. Or simply an engine. Obviously, that is an
Okay,
engine, but that is using the gas turbine. Brayton cycle.
okay,
Brayton cycle is the cycle for gas turbine. It is also called a
okay.
gas turbine cycle. Okay.
Yes.
So, and when I asked you that what is the basic disadvantage of a closed cycle, it will be, see, in a closed cycle you are recirculating the same air,
Yes,
so the same air will be depleted from oxygen.
yes, yes, sir.
So then you have to supply new, either new air or new oxygen. If you supply new
Okay,
air, then it is an open cycle, and if you supply oxygen, then you have to do some I mean another supply line. Okay, but if you use the open cycle, then you don't have to take, I mean you don't have to think about the oxygen again and again, that
oxygen
from
requirement.
where it will be coming. But there are also some advantages and disadvantages. I mean there are also some disadvantages of open cycle also. So please, I mean look into those things. See,
Okay.
in ISRO, you can always expect that some or the other questions will be asked from airplane,
Yes,
from airplane. So try to know everything about an airplane, the basic
yes,
things,
sir.
the engine. So for fluid mechanics, try to know something about aerodynamics, the basics. See, aerodynamics doesn't mean that you have to know, I mean, in very large, great details. Okay,
Okay, sir. Okay, sir.
so you don't have to think about that, but you should know that the basic fluid mechanics that is connected to, I mean, aerodynamics that I have I mean asked you here. Okay,
Okay.
the basic thermodynamics about an airplane engine, the
Okay.
basic material science and manufacturing about an airplane. So which
Okay.
material is used to make engine, which material is used to make the airplane body, all these things.
Yes, sir.
Otherwise, I have found that other than the fluid mechanics, your knowledge is sufficiently good.
Okay, sir.
Okay. Okay. So do you have any question further?
Sir, the pressure cooker question,
Pressure
is
cooker
it
question.
what?
Yes, that was also right. That was also right.
And I had a small doubt from previous doubt. I mean, I had to ask from my previous mock interviews. Where it was.
Is your interview date out?
Yes, sir. It is on 7th of August. I
Oh,
remember.
7th of August. Okay, okay,
Yes,
okay,
sir.
okay.
And I have also planned for the travel. I have also. I mean, I have
So
already planned all travel
VSSC,
plan.
right?
Yes.
VSSC. Okay, okay, okay. Okay, tell me if you have any question.
Sir, you had asked one thing, phase change material.
So yeah, phase change material. Okay. So phase change material is something which changes its phase if you give it heat or if you take heat out from it. Okay. So it is
I've
it is
been to
used
this.
it is used to sometimes generate energy. Okay. Or it is used to sometimes for insulation. Okay. For example, it is sometimes used keep to keep some homes in some in some hotter region to make them cooler. So if you just apply some phase change material in the bricks in the walls of the houses, if you apply some phase
Okay,
change
sir.
material, then when the temperature will rise up to a certain level, the phase change material will take that heat and
Extra
change its
energy. Okay.
phase and change its phase. So by changing its phase, it will absorb that heat. But when it will absorb that heat, the temperature will not change because it is changing its phase.
Phase
So that
change.
is the
Okay.
beauty of phase change material. It will absorb that heat, but it will not change the temperature. Okay, don't worry. I mean, phase change material is important, but it doesn't matter that I mean, if you could not answer it in the interview because you have answered almost all the questions correctly. So don't worry.
Okay, sir. Actually, I am not finding out the doubt. Actually, I will ask later. Uh,
Mhm.
actually, the doubt I was not finding out why I written that. I had a small doubt from
Okay, so
previous interview.
that you will
So
ask
I
now or after the interview?
later
Okay, okay,
after the interview maybe.
okay. So now let us close your interview. Okay.
Okay, sir. Thank you, sir.